Hey everyone, welcome back to the Deep Dive. We're diving deep into all those big announcements and insights that came out of NVIDIA's GTC 2025 presentation. Specifically, we're going to be focusing on PCMag's YouTube breakdown of the event.
Yeah, they managed to pack a ton into that presentation. If you blink, you probably missed something big.
Right. We're talking about everything from their latest GeForce graphics cards, which some of you might already be drooling over,
Yeah.
to some of their really big moves in the automotive industry. Oh, and a total revolution when it comes to the power of data centers. Did you see that?
Oh, and don't forget about the robotics advancements. Nvidia is really pushing the boundaries of what's possible. There was a whole section on that.
Yeah, that was pretty mind-blowing. But look, we know you're busy and you probably don't have time to sift through hours of presentations and keynotes. So today, we're going to pull out the really important stuff. You know, the big takeaways, the stuff that will really help you understand the future that NVIDIA is building.
Yeah, no need to get bogged down in all the super technical details. We'll keep it clear and to the point.
So whether you're a hardcore tech enthusiast who builds their own computers or just someone who's curious about how technology is shaping our world, stick with us. We'll break everything down in a way that makes sense. Okay, so why don't we start with what NVIDIA is probably best known for, GeForce.
Well, this GTC was a big one for GeForce. They actually celebrated their 25th anniversary. It was a quarter century of innovation in graphics.
Wow, 25 years. That's a really long time in the tech world. You know, it's amazing to see how far things have come. It makes you think about what the next 25 years will bring, right?
Yeah.
But to mark this anniversary, they went ahead and unveiled the new GeForce 90 series, including the top-of-the-line 5090, all part of their new Blackwell generation of GPUs. What do you think?
It's an impressive lineup.
Mm.
They claim a 30% reduction in size and a 30% improvement in heat dissipation compared to the 40 series. And of course, they're touting some incredible performance.
Yeah, a 30% smaller volume and better heat management, that suggests a real improvement in the design, right? So what does that mean for the average person? Well, that could mean more powerful graphics in smaller, quieter, and more energy-efficient machines. And it also means that all that amazing power is going to be packed into a much smaller space, less bulk.
Right. It's not just about making things incrementally better. This seems like a real leap forward. And one of the things that stood out to me was how they're really leaning into artificial intelligence. They actually highlighted how AI is now being used for 100% path-traced, real-time computer graphics.
Now, for those of you who aren't familiar with path tracing, it's basically a way of simulating light in a virtual scene. They trace the paths of light rays to create these incredibly realistic visuals, and traditionally that takes a ton of processing power, especially if you want to do it in real time. But get this, NVIDIA is using AI to essentially infer 15 out of every 16 pixels. Think about that for a second. That's a huge reduction in the computational workload.
It's mind-blowing.
Yeah.
It really is. I mean, think about the implications. We could be on the verge of seeing incredibly lifelike graphics that don't require top-of-the-line hardware.
Exactly. It's going to be huge for things like cloud gaming, too. Imagine streaming games with those kinds of visuals. I mean, it could be a game changer for people who don't want to spend a fortune on gaming PCs. But it's also funny, right? Because as NVIDIA pointed out, GeForce was actually instrumental in bringing CUDA to the world. And that was the parallel computing platform that really helped drive that explosion of AI in the first place. So now AI is kind of coming full circle, right? It's fundamentally changing how computer graphics are created.
It's a perfect example of how technology evolves and how these different fields influence each other. And speaking of AI, let's talk about their partnership with General Motors in the automotive industry.
Yeah, this was a big one. GM is actually going to be using NVIDIA's technology to power the AI in their future self-driving vehicles. And they're not just talking about the cars themselves, they're looking at how AI can impact every aspect of their business.
They're using AI in manufacturing to, really revolutionize how cars are built. It's going to be AI for everything, for enterprise operations, for car design and simulation, and of course for the AI infrastructure that's going to be right there in those vehicles, enabling the autonomous driving.
So this isn't just about making cars drive themselves. It's a whole new approach to how cars are designed, manufactured, and used. For the average person, this signals a major commitment from a traditional car manufacturer to really embrace AI. It's a pretty big deal.
And if you zoom out even further, you can really see how the advancements in AI are starting to affect every part of our lives. They're not confined to the digital world anymore. This partnership really shows how much momentum there is behind autonomous vehicles and how established industries are willing to completely change the way they do things.
But of course, safety has to be the #1 priority, especially when you're talking about self-driving cars, and Nvidia knows this. That's why they have this internal initiative called Halos, which is entirely focused on automotive safety.
Yeah, what impressed me about Halos is how comprehensive their approach is. They're looking at safety from every single angle. They're thinking about the silicon chips, the software systems, the algorithms they use, and even the diversity of their development teams.
They even mentioned that they're the first company to have every single line of code, all 7 million lines, independently safety assessed by third-party experts. That's a pretty big statement.
It really is. When a company is willing to subject that much code to external scrutiny, it shows how seriously they take safety. And it's not just about the technology itself. They're focusing on transparency and explainability too. That's going to be crucial for building public trust because people need to understand how these systems actually work.
So that's the automotive side of things. But let's switch gears and talk about data centers. This is where things get really powerful with their new Blackwell architecture.
Oh yeah, Blackwell's a game changer. These GPUs are already in full production, and they really represent a major leap forward in how we think about computer architecture.
So they showed this comparison between their old HGX system, which had 8 GPUs, and the new Blackwell system. And the new system actually has 2 Blackwell GPUs in a single package, and then 8 of these packages are all connected together. Sounds like a lot, right?
It's an incredible amount of processing power
Mm.
in a very compact space. And they've really re-architected the way these GPUs communicate with each other. They call it the MVLink. And it's now a disaggregated switch. So imagine like a super efficient highway system where every single processor can talk to every other processor instantly without any traffic jams.
That's a great analogy. So instead of that localized communication within the old HGX unit, you now have this centralized high bandwidth network. And that network lets all of those processing units work together really seamlessly. And they're using 18 of these switches across 9 racks of equipment. It's pretty incredible when you think about it.
It really is. And all of this is housed in liquid-cooled racks, which is another big change. It's much more efficient in terms of energy consumption and heat management. In fact, each of these new racks can deliver the same compute power as 2 of their old air-cooled systems.
So what does that mean in terms of raw power? Well, they're claiming 1 exaflop of computing power in a single rack. To put that into perspective, that's a quintillion floating point operations per second, which is just mind-boggling. And then they showed a 72-rack configuration of this Grace Blackwell MVLink system, and they called it the most extreme scale-up the world has ever done. That's a bold statement.
It is, but the specs back it up. We're talking about exaflops of compute, 570 terabytes per second of memory bandwidth. It's insane. And this is all driven by the massive demands of AI. These models are getting incredibly complex, and they require huge amounts of processing power to train and run.
Right. And to manage all of this power and complexity, they announced something called Nvidia Dynamo. They called it the AI Factory Operating System. So what is that exactly?
Well, it's completely different from traditional data center operating systems like VMware. They're designed to manage all sorts of enterprise applications. But with Dynamo, the main applications are going to be AI agents. And Dynamo's the OS that manages those agents in something they're calling an AI factory. It's the future of data centers.
So Dynamo is like the conductor of this massive orchestra of AI, right? And the name is interesting too. It's a reference to the dynamo instrument that was essential during the Industrial Revolution. It converted mechanical energy into electricity. And the idea here is that NVIDIA Dynamo is going to be the software that enables the energy of AI.
It's a great analogy. And they weren't kidding when they described it as insanely complicated software. It has to be. It's managing this incredibly complex web of computing resources, all dedicated to running these demanding AI workloads.
Yeah, makes sense. Now, they also introduced the DJX systems, which they're calling the AI computer. These seem to be more targeted toward individual researchers and data scientists.
Yeah, the DJX lineup includes the DJX Station, DJX Spark, and DJX Station, and they're really designed for people who are working on the cutting edge of AI research and development. And the good news is you'll be able to get these through companies like HP, Dell, Lenovo, and Asus. So this really powerful technology is going to be much more accessible.
And they give some pretty impressive specs for a typical DJX system. We're talking about 20 petaflops of compute, 72 CPU cores with a chip-to-chip interface for lightning-fast communication, HBM memory, and even PCI Express slots for adding GeForce graphics cards. They really thought of everything.
It's designed to be the ultimate AI workstation. And it's not just a single machine. It's a whole ecosystem of enterprise solutions scaling from these workstations all the way up to massive supercomputers. They're covering every base.
And finally, let's talk about robotics and what Nvidia is calling physical AI. This is where AI really starts to interact with the real world in a very tangible way.
They made a strong case for why robots are so important right now. They're the only way to truly interact with and manipulate the physical world, and they're becoming increasingly essential because of the projected global labor shortage.
Yeah, they mentioned that there could be a shortage of at least 50 million workers by the end of the decade. And they even talked about how robots might cost around $50,000 per year. That sounds like a lot, but it could actually be cheaper than hiring a human worker, especially when you factor in things like benefits and training.
Right. And think about all the tasks that robots could do. They could work in factories, warehouses, hospitals, even in our homes. The potential is huge.
Yeah.
And NVIDIA sees their Omniverse platform as the operating system for physical AI. And they announced two really interesting additions to Omniverse, Cosmos and Newton.
Okay, so Cosmos is this generative AI model that's been trained on a massive data set from Omniverse. It can actually create an almost infinite number of realistic virtual environments for training AI agents, like robots.
So instead of having to collect tons of real-world data to train robots for every single scenario, they can use Cosmos to generate these incredibly detailed virtual worlds where the robots can learn and adapt. It's a much more efficient and cost-effective way to develop robots that can handle the complexities of the real world.
And then there's Newton, which is their new physics engine. But this isn't just any physics engine. It's specifically designed for robots. It can handle all sorts of complex interactions, like simulating tactile feedback, enabling fine motor skills, and controlling actuators. And the best part is it's GPU accelerated, so it can run these simulations in real time.
It's a game changer for anyone who's working in robotics development. And to top it all off, they announced that they're open sourcing their Groot N1 robotics platform.
Wow, that's huge. Open sourcing a platform like that is going to really accelerate innovation in the entire field. It allows developers to build upon NVIDIA's work, share their own advancements, and collaborate on a much larger scale.
It's a great move by NVIDIA. They're really showing their commitment to advancing the field of robotics as a whole.
So, to sum it all up, NVIDIA's GTC 2025 presentation was a mind-blowing showcase of cutting-edge technology. We saw how AI is transforming everything from graphics cards to self-driving cars, data centers, and even robots.
And what ties all of this together is NVIDIA's deep understanding of AI and their ability to create the hardware and software that makes it all possible. We're seeing the convergence of different fields like never before.
It really makes you think about the future, doesn't it? As AI continues to evolve and become more powerful, what kind of world are we going to live in? What new possibilities will emerge? It's exciting, it's a little bit scary, but it's definitely something worth thinking about.
I think it's safe to say that the next few years are going to be really interesting. We're on the cusp of some major breakthroughs, and NVIDIA is right at the forefront.
So that wraps up our deep dive into NVIDIA's GTC 2025. What are your thoughts? What are you most excited about? What concerns you? Leave a comment and let us know. We love hearing from you. And as always, thanks for listening.
And we'll see you next time on The Deep Dive.